is 9J. Plus by omega BC, still the same, minus 90K. Cross RB from point D. Okay, so point D, so we have to look at our dimension. The gear is 0.3. Okay, 0.3 now. So 0.3 B, so minus 0.3 I. Okay. So this will be equal to 9J, negative, negative, positive, K cross I is positive, plus by what? 90 plus by 0.3 is equal to 27. Hey, Eugene, seriously? 27J. So the outcome is positive 36J meters per second. Okay, so feel comfortable. You know that if it's on a rigid body, you can take either points. The answer will be, has to be the what? Same. Are we clear? That's the beauty for trusting the math. I want you to have that confidence. Okay, I don't want you all to just look at the solution manual. Oh, we have to use this point. We have to use this point. Not necessarily true. Okay? During the term test, you don't have solution manual in front of you. Okay? So now the next thing is, we now know what? We now know our VB, right? So we know our VB now. So we can state that VB, note that VB is equal to what? VA, right? Why VB is equal to VA? Because at this point, when the gear mesh, the velocity has to be the what? Has to be the same, okay? So now let's focus on gear A. Okay, let's focus on gear A. And gear A, I'm just sketching it. You have a point at the center known as point, oh shoot, point what? Point E, right? And we want to know what is our VA. We know our VA, right? We want to know our omega AE. So again, same formula. So VA is equal to VE plus by omega AE cross R A from point E. So we know that VE is equal to 0. Sorry, we know our VA. VA is equal to 36J. Okay, 36J. VE is equal to 0 plus by omega AE is going anti-clockwise minus or positive omega AEK cross R point A from E. Okay, so the diameter of the gear is what? 0.2. Yeah, 0.2. So 0.2 AI. Okay. So this will be equal to 36J. And this is equal to K cross I is positive 0.2 omega AE J. So omega AE is equal to 0.36 divided by 2.2. .8. Is it 1.8? Wait. 0.36. Why is 0.36? Come on, Eugene, wake up. 36 divided by 0.2 is equal to 180. Positive means the direction is correct. Radians per second. Are we clear? Okay. Planetary gears. What course are you all doing gears now? To what? 2D. You're doing planetary gears also or no? right? You look at planetary gears. What are you doing? You're calculating gear teeth or what? Yes? Don't know yet? Next week. Okay, nah, you know this week. You tell no problemo. Know how to calculate the velocity, yo, right? Right? So when you see Mickey Mouse, no, Mickey Mouse stuff, right? Right? Yeah, I know that. Okay, easy, right? Is it difficult? Like the first time you see, like, holy crap, not necessarily true at all. Okay, I better be watching my language. But anyway, so let's do another one. Oh, Friday, Eugene. Seriously? Oh, okay. Hey, I can give you any gears. Okay? I can throw any junk at you. Okay. The analysis is still the what? Same. Nothing different. I'm going to show you now. Now, when you look at this, right? When you look at this the first time, you guys look at it the first time, what comes to your mind? Holy shit, isn't it? Right? Now we got one gear on top, one gear at the bottom, one gear at the center, one gear outside. Still the same. Planet, sun, wind. Don't care how many what. Don't be bothered how many gears. Yes. Okay. Okay. Can you identify which is the sun? S, right? Can you identify which is the planet? The planet rotates around the sun. P. Can you? There you go. Yes or no? You can visualize it. It's not that bad. Okay? I'll be frank. When I was an undergrad, when this question came out, we were all scared shitless. Really, really scared. Okay, I don't want you to be scared. Okay, you should not be fearful. Okay, right? You shall not fear. Okay, right. So let's look at this problem. I have not a clue what they want. The planetary gear system is used in an automatic transmission of an automobile. Any idea what's an automobile? A car, right? Have to be automobile for crying out loud. By locking and releasing certain gears, it has the advantage of operating the car at different speeds. Consider the case where the ring gear R is fixed. Remember what I told you guys? Always one of the gears has to be what? Fixed. That theory still what? Stand. Okay, did I write down? Did I write this down? I did not. So I write down here, note in planetary gear system, one of the gear has to be what? I.e. omega is equal to what? Only one. Okay, you don't need all of them. Only one. Okay. Then omega s is rotating at 5 radians per second. So omega s is equal to what? 5 radians per second and is going anticlockwise plus by 5k radians per second. Determine the angular velocity of each of the planetary gears P and the shaft. So we want to determine our omega P and our omega A. Okay. Okay. So this is our A, right? And A is the shaft. Okay. So now I'm only going to deal with one gear. Okay, you know to do with two, not necessary because it's the same, it's symmetry. So now I'm going to sketch the sun. Okay. So this is the center. So I'm going to call this gear S. And then we have a gear P. And our focus again, we are going to align this in vertical, where the contact is. It is our math. Why I say that? Then you only need to handle one component. You don't need to handle two components. Okay. Okay. So we know that over here, different color. We have what we are very clear is we know that this is our VS. Okay. At this point over here, I'm going to call it our VR, and our VR is equal to what? 0, because the velocity is specified as 0. We know that VP, right? No, okay, I don't know. I'm going to assume VP is going in this direction. Okay, I don't know what direction it's going, but I'm going to put VP is going this direction, the planet is going this direction, and this is assumed. Whatever that I don't write assume, I'm very sure of the direction. We also know that this is rotating at omega s, and this is rotating at omega p. Are we sure about the rotation? Anyone? Are we sure? We are very, very sure. This is not an assumption. The only thing that I'm assuming down here is I have not a clue if VP is rotating at that same direction. I don't know. Okay, that's the only thing that I'm assuming. Okay. So I'm going to now call this my point O. At the center over here is my point O. Okay. Over here are my point S. This over here is my point S. Okay, it's my point S. I don't know why I say this is VC. This is VS. Okay. Can you change, please? Okay. So from now, after doing the first one, you can see how this can be solved, yes or no? Okay. Now let's look further. VP will affect the omega A. You highly agree or disagree? VT, the planet, will affect the shaft A labeled in the diagram because they are linked with an arm. Yes or no? They are linked with an what? With an arm. And this arm is a rigid body. There you go. Right? So that's why VP will affect what? Omega A. Right? So we also know if that's the case, right? We have to determine VP first. So from here, we have to determine VP first, but before we have to determine VP, we can determine VS, okay? So the first stage is to determine VS, okay? Or we are going to determine VS, okay? I will like to write down the solution procedure. Okay, so we know that we have Vp, right? So the first thing we have to now, given the equations that we have or whatever that we have now, we first have to